Hi, this is Mrs. Clark. Welcome to my video on adding and subtracting polynomials. We are going to write down some notes about the work that we've done as we work through our lesson. We're going to start with information about adding polynomials. Then we'll do subtracting. We'll do an example of both as well. Let's get started. So when we're adding polynomials, we want to remember that we need to only add the like terms. So add only the like terms. And we want to remember to add the coefficients and not change the exponents. Let's do our example of adding, and then we'll come back and talk about subtracting. So example 1 is adding. So I'm going to write it out first, and then I will read it to you. Okay, it is kind of long. We have two polynomials. Both are represented by the parts in the parentheses. So this first one has 4 terms. It is 2x to the third power minus 3x to the second power plus x plus 1. And that's all in parentheses to show that that's the first polynomial. Then we have a plus sign, so we're adding them. And in the second parentheses, we have 5x to the third power plus 2x to the second power minus x plus 5. So the parentheses are here just to show which terms, to group the terms together, to say this is a polynomial and this is a polynomial. And then between it is telling us what to do. We're adding them. So directions for something like this might just say simplify. Let me add that up here. Okay. So what we need to do when we're adding is we don't really need to keep the parentheses. So we can actually drop those if we'd like to. And you can treat this like a really long expression where we're just combining like terms, because adding doesn't really change anything about either of the polynomials. So I'm going to drop the parentheses and rewrite it as a really long expression. So 2x to the third power minus 3x to the second power plus x plus 1 plus 5x to the third power plus 2x squared minus x plus 5. And I'm going to make a note here that says if adding, you can drop the parentheses. All right, so what is important to do at this point is to combine the like terms. How you do that is going to depend on the style that you like. If you like the way that we were doing it before, when we were looking at long expressions and we were just combining like terms, you can do that. Underlining the things that are like, circling the things that are like, boxing the things that are like. You need to do something to show how you're collecting which terms are like, so that that's your work. So you may do something like underline this and say 2x squared, x to the third power is one term. I'm now going to combine that with 5x to the third power as well, because those are like, so I underline them both. I may do a squiggly underneath the x squared term to show that that's going to go with this other x squared term. You could circle the x term, don't forget to include the sign, and circle this x term with its sign. You could put a double underline underneath your constants to show that those go together. And you can collect those together by looking at them and saying 2x to the third and 5x to the third is going to be 7x to the third. Let me write here, combine like terms. And we can do 7x to the third. If I combine my x squareds, I have a negative 3x squared plus 2 x squared, so that becomes negative 1x squared. I'm just going to write negative x squared. I don't usually write the 1. Positive x and a negative x are going to cancel out, so I'm going to have 0x. And then positive 1 and positive 5 makes positive 6. So I do need to make sure that I'm not including this 0x in my final answer. So my final answer would be 7x to the third minus x to the second power plus 6. And I'm going to write that note here. Don't include 0x in final answer. Now, the way we did it throughout the lesson is instead of doing it this way with the underlining and the circling and all that things, is we lined everything up vertically and did it like a big addition problem. We can also do that. So if you want to do it that way, it would look something like this. We would say 2x to the third power minus 3x to the second power plus x plus 1. And then underneath it, I would line up the like terms. Plus 5x to the third power plus 2x to the second power minus x plus 5. And then I would do it like just a big addition problem, like we've been practicing. So 1 plus 5 is 6, so it's a positive 6 here. These are going to cancel out. Negative 3x squared plus 2x squared is going to be negative 1x squared, or just negative x squared. And then 2 plus 5 is 7, 7x to the third. So you're just adding the coefficients and not changing the variable or the exponent. So however you want to do it, if you want to show your work this way by showing your like terms and then combining them, or you want to show it this way by lining it up and doing it vertically, either way is fine. So that's adding. Subtracting is very similar, but we noticed when we learned this that there were a few little pieces that make it difficult because when you're subtracting regular numbers, your number on top is always bigger. You don't have any negative numbers, but in polynomials, we know we have negative numbers. Our numbers are not always going to be less than 10. They're not always going to be subtracting a bigger number on top. So we have to remember a couple things. What we're going to do is we're going to try to change a subtraction problem into an addition problem by doing these things. So I'm going to write that here. Change subtracting or subtraction to addition by, and then we're going to list a couple things. The first thing is going to be to distribute the negative sign to the second polynomial. And what that means is we're going to just change the sign of every term. So change the sign of each term after the minus. And then all you're going to do is add your like terms. It becomes a problem like this one. So by making a problem like subtraction into this problem, once we make that, do that first step, it's just like this. So here's our example of subtracting. This one's not quite as long, so I'll read it to you as I write it. Parentheses, 5x to the second power minus 3x plus 4 minus 2, close your parentheses, then subtraction. Open a new parentheses, 2x to the second power minus 4x minus 3, close your parentheses. All right, so that's first polynomial is 5x squared minus 3x plus 4. Subtracting the second polynomial, which is 2x squared minus 4x minus 3. So first thing we need to do is change the subtraction to addition. And then we need to distribute the negative number. So we're going to keep this first polynomial exactly the same. 5x squared minus 3x plus 4, but I'm going to drop the parentheses. Then I'm going to change this to addition, because what I'm going to do is I'm going to take this negative sign and I'm going to apply it to each of these terms. When I apply it to the first term, instead of a positive 2x squared, it's going to become a negative 2x squared. When I apply it to the next term, instead of a negative 4x, it's going to become a plus 4x. And when I apply it to that last term, instead of a minus 3, it's going to be a plus 3. Once I do that, this problem looks exactly like this problem. I'm just going to combine the like terms, whether you do it with underlining and circling or you do it with vertical addition. Either way, we're just adding. So we got rid of the difficult part. So if I combine my like terms, I have this x squared and this x squared term that will go together. I have negative 3x and positive 4x that will go together. And I have plus 4 and plus 3 that will go together. So if I do that, 5x squared plus negative 2x squared is going to be 3x squared. Negative 3x plus 4x is going to be positive 1x, or just plus x. And then plus 4 and plus 3 is going to be plus 7. So my final answer for this one will be 3x squared plus x plus 7. If you go to do it the other way, oh, I forgot an or up here. If you go to do it the other way, you would line them up vertically. So 5x squared minus 3x plus 4. And instead of using this first one, I would use the second one where I made an addition problem and changed all the signs. So minus 2x squared goes under here, plus 4x goes under here, plus 3 goes under here. And now it's just a big addition problem. So adding it down, 5 plus negative 2 is 3, so that's 3x squared. Negative 3 plus 4 is 1, so that's plus 1x or plus x. And positive 4 plus 3 is positive 7. So after, I'm going to make a note here that says after changing the signs, we're going to line them up. What we do want to make sure that we're paying attention to, and I've mentioned it before, but I'm going to have us write it in our notes now, is that our final answer is always in what we call standard form. So I'm going to make a note of that here, and then we'll write down, I'm going to use some space over here to write down what standard form is. But I'm going to say a little star here, always put your final answer in standard form. So standard form, we mentioned it briefly, and I gave you kind of an unofficial definition of it, but I'm going to give you a more official definition of standard form. And again, write down as much as you feel you need to so that you really get what it's saying here. So standard form, I'm going to put a definition. It's the terms are arranged in descending order of their exponents. So that means we're starting with the highest power and ending with a constant term going lower in power as you go along. So I'm going to say the terms are arranged in descending order of their exponents. So if you want to make a note of what that means, you can add starting with the highest power and ending with the constant term. If you need to write that in a different way so that you understand it, that's great. If you need to change any of the words, please do. I'm going to give you an example. We're going to start with a polynomial not in standard form, and then we'll put it in standard form, because there's one other vocab term that I want to share with you. So I'm going to start with 5x minus 3x to the third power plus 7 plus 2x squared. And we're going to put that in standard form. And so what that means is that I have to start with my x to the third term, because that's the highest power, and then I'm going to go to my x squared term, because that's lower. Then I'm going to go to my x term, because that's really a first power. Then I'm going to have my 7 at the very end. So I'm going to rearrange them. I'm not really doing any combining of anything, but if I'm putting it into standard form, I have to start with that highest power. So I have to start with negative 3x to the third. And then next would be my x squared term, so plus 2x squared. And then next would be my 5x, so that's a positive, so plus 5x. And then last would be my plus 7, my constant. So this is standard form. And one important part to know about that, because this is going to start coming up, is that this coefficient in the front, this is one of the reasons why it's important to put it in standard form. We call that the leading coefficient, because it's the leader. So make sure you have all that vocab written down, because you're going to need to use these words when you're describing things. And like I said, when you're doing these problems, whether you do it like this first way or the second way, it doesn't matter to me, whether you're lining them up and doing them addition this way or combining like terms, just that you're showing something. There's not a lot of work to show for these problems, but this can help me see your process, or even just underlining, circling, boxing, the things that are like can also help me see your process, so that we can make sure we're all getting to the same answer. So cut this out and glue this in your notebook. Let me know if you have any questions, and work on your CYU.